Okay. 1.1 is what we're going to start with. And geometry is a bunch of vocab, okay? So if we can study vocab 5 minutes a night, then we're going to be much better at geometry. Okay? Yeah, you can do Quizlet. I'm not putting one together, but you can put one together for the whole group. Okay. So right now, chapter 1 especially is going to be lots of vocab. First is points. Okay? Points. Occupies no volume or space. So it doesn't take up any volume, it doesn't take up any space. It's a location and it's represented with a dot. Okay? A line. A line can be defined by 2 points it passes through. So here's the deal. If I have a line, okay, in order for something to be a line, it has to pass through 2 points, at least 2 points, a minimum of 2 points. Okay? The way that we show the way we would name this line, we would name this line AB, okay? The way we would show that in geometry is you would put this over top of AB. That stands for line AB, okay? You have 2 arrows on the end because a line never quits, right? It's always going forever. Now, a line segment is a part of a line. So if we look at that green line, line AB up there, we actually have 2 separate line segments, okay? We have segment AB and we have segment BA. Or we have, technically we have 1 segment, we have 2 rays. So we have a segment AB. So segment would, in this case, would be from this point to this point. This is my segment, okay? And the way we represent that is with a segment line over it. So when you're dealing with a segment, you don't have arrows. Does that make sense? It's a portion of it. I'm taking it out. Okay?
Like an operation.
Yeah. I'm just pulling that little sucker out. Okay? So segment is a portion of the whole line. Okay? Endpoints. You have a question?
No, shit.
Okay. Endpoints are where the line segment or ray ends or starts, okay? So, here is a line segment, right? Segment AB. It has 2 endpoints. My endpoints are point A and point B, okay? Now, in order for us to take a look at a ray, let's go to a ray and then we'll talk about the endpoints of those. Okay? A ray is a portion of a line that starts at a point and extends forever in one direction. So here, in this that we used up here, I have ray AB right here, okay? An array does just that. If I want to name it, the one side doesn't have a point, the other side has arrow. Now, I have another ray up there. What's my other ray?
B.
A. Okay, so I have a ray that goes this way, BA, okay? Now, when I name it, I'm not changing the direction of my arrow, okay? I'm just changing the order of my letters, okay? So that ray is ray BA, okay? Order matters in geometry, meaning anytime I write something out with letters or with numbers or with symbols, the order you put them in matters. Because ray AB is different than ray BA. BA is going to the left forever. AB is going to the right forever. Total different things. Okay? And in ray AB, okay, my end point is A. Okay? But in ray BA, my end point is B. So I have different stuff going on there. Okay? And in a picture, they're going to give us lots of pictures in geometry where there's a lot going on. And they're going to say, identify everything you can. Okay? I personally in geometry use a lot of colored pencils or highlighters. Okay? Because if I can highlight like a ray always the same color, then I can remember what that looks like in my head. So maybe that's a little tip for you. Get some colors up in here. Okay? How are we doing so far?
Good.
Okay.
Let's make this simple.
You have line copied, you have line segment copied. Okay. Beautiful. The next thing we're going to talk about is a plane. And a plane is a 2-dimensional figure. Okay? A plane is a 2-dimensional figure. So, a plane, right, well, in our textbook, you're gonna see planes drawn like this. Okay? A plane is a two-dimensional figure. A plane continues forever in every direction. Okay? Forever in two dimensions. A plane can be defined by listing any 3 points on which are not aligned. So you have to have 3 points in order for there to be a plane.
You have to have what for it to be a plane?
You have to have at least 3 points
Okay.
that are not all on a consecutive line, meaning this. If I have this point A here, okay, and I have this point B here, my third point has to be someplace not on that line.
What?
In
Oh,
order,
so the third one can't be on a line.
on the same line, correct.
Pretty much you just.
Because at that point, I just have a line, I haven't defined that I have a plane,
Mhm.
okay? But if I have a plane, it's going to encompass at least 3 points, but they're not all going to be on the same line,
Okay.
okay?
So could it be on like the top line of that?
Yeah, it could be anywhere. I could have, technically I have 47,000 whatever points in here, right? So it can be anywhere on there, yes. But there just has to be 3 to make a plane. Otherwise, I have a line because 2 makes a line, okay? And they can't all be in the same row because it's just a line then. Okay. A postulate, somebody asked me yesterday, right? What's a postulate?
Me.
Okay, a postulate is a statement that is accepted to be true without proof. So, if it says this is a postulate, we say, okay, it's true. Okay? And then you use postulates to help prove other statements.
So postulate is like a thing, and then the what thing that you said is like facts.
Right. Okay? So postulate is a statement that is accepted to be true without proof. And postulates are used to help prove other statements. I'm telling you, chapter 1's a lot of words, okay? It's gonna feel like you're in English class for a little while. I'll give you a minute to finish this and then we'll move on, because I got 7 more slides.
Wow.
Of this,
Just for today?
For today, yeah.
Love
of
notes.
like words,
Some are like examples and questions, and then some are like postulates and, yeah.
Yay.
I'm gonna get, the next slide is gonna be all postulates.
Postulates is a weird word.
Oh, there's lots of weird words in geometry, just wait.
Yeah.
Oh,
Sam.
fun.
I know, right? Sorry, Sam, your head's too big, he's saying.
thank you.
Okay, postulates are a statement that's accepted to be true without proof. Postulates are used to help prove other statements. Are we almost ready?
Yes.
I'm gonna move to the next one. Okay, postulates, lines, and planes. This is just a diagram, I lied, this isn't the postulates yet. This is just a diagram of a line, a plane, a bunch of stuff. So I'm gonna ask you some questions and you're gonna go off of that diagram, got it? Okay, who can name a point on that diagram? Just shout it out.
D.
Hey.
D, A, B, they're all points, right? Okay? Tell me a line segment on that.
C-A.
C, A, what else?
CD.
C, D, what else?
D, C.
D, C.
D.
Uh-huh.
A, B.
Okay, now, little sneak peek to something that's gonna happen tomorrow probably, or whatever, Monday. You see how AD is a segment? Yeah, but what happens with, with C? So AC is a segment, CD is a segment, and AD is also a segment, correct?
There's a third one on the line. Is it ACD?
ACDC.
Is it line
Yeah.
AC?
No, just stop. Wait, stop.
Oh, sorry.
AD is made up of 2 components, right? AC and CD, okay? So we're eventually gonna get a postulate that's called segment addition postulate. And it's basically saying any 2, 3, 5, 7 segments that add to be another whole segment, you can do that. So we can do some math and plug some algebra in there.
Yay.
Yeah.
Yeah.
Yay, there we go,
Fun.
yay. Okay, so basically, a segment addition postulate would say AC plus CD equals AD, right? The little piece plus the middle piece equals the big piece, okay? Tell me a ray that's on there.
B, E.
You need two things to make a ray. I need two.
DB.
DB would be a ray. What else?
CA.
CA would be a ray. What else?
CB.
CB. What else?
DA.
Good. Those are it. Beautiful. Or AB or BA.
Yeah.
Okay. Beautiful, beautiful, beautiful. What 3 points can make up a plane in there? DBE. We have to use that E because it's not what?
On the
On
the line. Beautiful. Awesome, awesome. Okay. Now, points, lines, and planes postulates. Here's some easy ones. Okay? A line contains at least 2 points. You need to write this down. You're going to use this on your homework too to help prove stuff. Okay? We're going to get familiar with this. This is point, line, and plane postulates. On that amsco.com website too, this is all on there too. Okay? So the first postulate we're going to talk about deals with a line. It says a line contains at least 2 points. That's a fact, they're giving it to us. Okay? A line contains at least 2 points. So that's the first postulate you're going to learn, that a line contains at least 2 points. The second postulate we're going to talk about and going to work with is exactly one line passes through any 2 points. So if I have 2 points, only one line can pass through there. Not 2, not 3, not 5, just one. Okay? So exactly one line passes through any 2 points. The third one says, if 2 lines intersect, they intersect at exactly 1 point. Okay? This is a lot of stuff that we know is common sense, right? We look at something and we're like, well, yeah, that makes a point. Okay? If I have 2 lines like this, what they're saying is when they intersect, this makes exactly 1 point. Okay? Next, a plane contains at least 3 points that are not on a line. We just talked about that. A plane contains at least 3 points that are not on a line. Because on your homework or later on in geometry, they might say, hey, this is a plane, okay? And then they want you to like prove that something's a line. Well, you know that these 2 points are on the same line inside that plane, so you can prove it. So a plane contains at least 3 points that are not on a line. Next you have exactly one plane passes through any 3 points which are not on a single line. Kind of redundant, yes? Okay. Exactly one plane, but see how above it says a plane contains at least 3 points that are not on a line? Now it's telling us only one plane, exactly one plane passes through 3 points that are not on a single line. So I can't have 2 planes, I can only have one with 3 points. Okay? With the same 3 points. And then it says, if 2 planes intersect, their intersection is a line. So if this plane, okay, and this plane intersect, I have to be good at drawing this, I'm not good at drawing. Sorry. So anyhow, when these 2 planes cross, I can do this better with paper. No, give me one. And I'll show you. Okay. So if I take this piece of paper and I cut it into 2 planes, I'm gonna pretend that these are planes.
Oh wait, what's the purpose of lines?
Yeah, I'm not a good drawer, that's what it's for.
Oh, okay.
Okay.
Are those exact scissors?
That's
In
one
my
my
locker, like.
Okay, so these are both planes, yes?
Yeah.
Yes.
When these 2 planes intersect, okay, if they intersect like this, we're to pretend this works perfectly. okay? When they intersect like that, right where they cross, this part here is a line.
Okay.
That's what that's saying. So when two planes intersect, they create a line. Okay. And then the last one says if 2 points are in a plane, then the line containing those points is also in the plane. That's kind of common sense too. Well, yeah, if the points are in the plane and the points are on a line, the line's in a plane.
I'm not writing that
What?
down. I said I'm not writing that down.
You're like, I got that one.
Too
That's-
much for me to know.
Okay. Then, I think the next slide has problems. Well, kind of problems. Like, you're gonna tell me which of these works with the statement I give you. That's how your problems are tonight.
Hey, that's fine with me.
Okay.
We'll do that tonight, so it'll be Sunday night.
How we doing? How we doing? Almost done, okay, that's fine. And you with us? You look tired. I said you with us?
Yeah. Oh, yeah.
Okay, I'm gonna add to this. This is why I didn't quite draw it all the way out. Okay, so these are gonna be lines. Beautiful, okay? And where you see a letter, there's a point there. Got it? Okay. And then I'm going to ask you this. Okay. I'm gonna name this line, line M, and this line's gonna be line N. Anytime you see little letters like that, that's the name of the line. It's not a point on the line, it's the name of the line, okay? And we're gonna name this one line K. Okay? So, it says lines M and N intersect at point D and G, okay? At points D and G. It says determine which statements are true about the diagrams. Explain your reasoning. So if it says lines M and N intersect at points D and G, is that true or false? False. Okay, what's false about it?
They don't.
Just talk.
They
Oh, they
only
only intersect G.
Okay, they only intersect at G, but how can I prove that that's the truth?
By math.
How can I prove that they only intersect at one point?
They could be
Yes, you
so
can.
considered-
Look back at what you,
Postulates.
yes, look at your postulates.
Exactly one plane has this, no,
It's not a
Exactly
plane.
exact one
Two
line
plane has a
set.
set,
Oh,
their
no.
intersection is a line.
Good, what? Not planes. We're not talking planes.
If
Two
two
lines
points
that
are
are
on
second,
a
it's
plane.
exactly 1 point.
Good. So I have to use that postulate to disprove that statement that they just told us.
Which number is that?
3. So they told us that the two lines intersected and created 2 points D and G. And we would say false because when two lines intersect, they intersect at exactly 1 point.
How about,
Did I miss
like,
that? Oh,
It wouldn't, that's the whole point.
Because they can't go like
Okay?
this. They
But
go
you
like
can't
that.
just tell me no anymore, you have to give me a reason why.
this is why.
we never had.
Okay? You have to give me a postulate that is a statement that we believe is true, right? And you have to back it up. I can't just go off your word or your smartness. I need to know why, okay? Now, line K. Only line K passes through X and Y. Is that true or false? And what postulate can you use to back up your reasoning? Why?
It's true.
Okay, why?
And
You know it, Courtney? Why?
exactly one line passes through in 2 points.
Yes, beautiful.
I was
And
trying
so
to
I would
find
write
out
that
what-
statement with it, okay?
Is it the first one?
The second statement. So it's the second statement because it says exactly one line. That's the one we want to use because it's exactly,
Everything is very exact.
it is. That's why I said order matters, everything matters in geometry, okay? So on your homework tonight, you're gonna need to use your notes a little bit to kind of, well, it's easier than flipping back and forth, right? To like figure out which statement backs up what, okay?
Can I just write it on the paper that I wrote?
Yes, of course. Okay. An angle. An angle is formed by two rays. Okay, what is a ray again?
The
one where like point and an arrow.
Point
A
and
point
an
and
arrow.
yes, it has an end point and it
Yes.
continues forever in one
Yeah.
direction. So an angle is formed by two rays. Okay, ray BA, ray BC. Okay? Now, where those 2 points, where those 2 endpoints meet is called your vertex. Okay, so I have vertex B here. Now, there are 2 ways to name this angle. Does anyone know the 2 ways to name this angle?
no, never mind.
What? Take a guess.
It's a cute one.
Okay. I don't want the type of angle, I want to name the angle. Yes,
So they were like AC.
kind of, you're on the right track. What?
Little bee.
Okay, angle B. Now, when you write it in your homework, I need you to write the angle sign with it and tell me it's angle B.
And then the line.
And then what's the other angle?
Angle.
CBA.
AC.
Okay, we can do it that way, technically we can do it three
ABC.
ways. So I can say
ABC.
angle ABC, or angle CBA. These two things are technically the same, okay? Really, all three are technically the same, but these interchangeable, okay? So,
You have to put them in alphabetical order? I feel like that was.
no, you don't have to put them in alphabetical order, you have to go in order so that B is always in the center, because B is my vertex.
Oh.
Okay.
See,
Does that make sense? Okay, so your vertex has to be the center, or you just name it by the vertex itself.
Is this our homework or are we like?
Why not?
Oh no, I'm gonna give you homework out of the book. Are we good? Okay, so there are 4 types of angles. And I didn't draw any of them up because I just want to discuss the 4 types because I think you're smart enough to know all of them. An acute angle, what do you know about an acute angle?
It's smaller than 90 degrees.
Okay, less than 90 degrees, that's what we need to know. Obtuse angle, what do we know about obtuse angle?
Bigger than 90
degrees.
Bigger than 90 degrees. What do we know about straight angle?
Straight is 90 degrees.
Nope, it's not 90.
Oh,
Yeah.
91.
180.
Oh, it goes like
I said that.
this?
Yeah, it's a straight line.
Okay.
A line is a straight angle,
I said
okay? And what about a right angle?
90 degrees. 90 degrees.
Exactly 90 degrees. So you guys know those 4 types, right? We're familiar with that? Okay. Okay, so if S lies within angle PQR, then the measure of angle PQS plus the measure of angle SQR equals the measure of angle PQR.
What?
Angle
What?
addition
What?
postulate. Okay, listen, this is where I said earlier, I give you a sneak peek, segment, big picture, right?
Oh, yeah.
Now we're gonna
I
go
guess so.
angle, big angle. Okay, so what it is saying is this, an angle addition postulate. So this is a postulate, this is a true fact, this is what we're gonna use to prove things. Okay? If I see that the measure of angle PQS, right?
Oh.
If I take that angle, and I take the angle SQR, and I add them together, what do I get?
PQR.
PQR.
Angle PQR.
Actually, can you do that again? I didn't understand what you're saying.
Okay,
Why does it have
if
to
I
be that
take
difficult
this
to look
small
at?
angle, angle PQS,
Uh-huh.
and I add it to the measure of angle SQR, meaning if this says that this is 32 degrees here,
Uh-huh.
and this says that this is 21 degrees here,
Uh-huh.
if I add 32 and 21 together,
53.
which is the whole angle PQR,
Okay, so you don't count the middle because, okay, yeah, I get it.
okay? So I'm gonna add the smaller portions, portion 1, portion 2 together to get the whole picture.
You said this is on the website, which one?
Amsco.com. Okay, so if I take the measure of PQS, which is 32, and I add it to the measure of SQR, which is 21, I'm going to get the measure of PQR, which is the whole angle, which would be 53, right?
Yes. Yes.
Okay. Because this little portion plus this little portion equals this whole part here, yes?
Nope.
That's what it's telling me with angle addition postulate, okay? And I can work that backwards. If I know the total and I know one of the small ones, I can find the other small one, okay? That's what we're gonna work with. Okay. Measure of angle ABC is 105 degrees. So, ABC, this whole thing is 105 degrees, okay? Then it says if the measure of angle ABD is twice the measure of angle DBC, what's the measure of angle DBC?
You divide it.
Well,
105 by 2.
mhm,
Yeah.
uh-huh.
No.
ABD is what?
Half.
Half.
Is twice.
Oh, twice as big
As
as
big.
DBC.
So if DBC is what? Give it a variable for me.
X.
Okay, so DBC is X, That means that ABD is what?
Twice as much as
2x.
2x equals ABC
2x equals 105.
No, 2x, what?
plus x.
Yes, plus x equals
105.
105.
What?
3x.
Wow,
Wait,
algebra
then.
and geometry.
105 minus
So
it.
then
Wow.
3x equals 105, you get what?
What's 105 times 3?
X, 3 goes into 105 how many times? 3
5.
goes into 10.
35. 35.
35.
So x is 35. Listen though, time out.
I think it's 90.
Time out.
Time out.
X is not 35, it's 35 what?
Times 2.
Times 2.
No.
Degrees. Divided by.
Thank you, Marco.
Yay! Good job.
That's small.
Degrees. If you do not have degrees, your answer is wrong, and I will mark it wrong
Been there a couple
when we are dealing with angles.
times.
Okay, so x is 35 degrees, right? Which means the measure of angle DBC is 35 degrees. So if I write it, this little m stands for measure of angle DBC. Oops, if I could write, that would help. Okay, measure of angle DBC would equal 35. There, I don't have to put the degree sign with it because I have measure of angle. Okay,
Both sides.
I'll still probably do
Cool.
it, just in case.
that's the type of stuff we're working on tonight.
Just in case.
I think this is
Warm
more
up.
like torture.